This is the combined gas law. And so far we have Boyle's law, which says P1 V1 equal P2 V2. And we have Charles' law, which says V1 over T1 equal V2 over T2. And we have Gay-Lussac's law, which says P1 over T1 equal P2 over T2. So if we do some algebra, and this should be obvious to you, and you don't need to be able to do it, but it results with the overall law, P1 V1 over T1 equal P2 V2 over T2. And this is called the combined gas law right here. And so we can do problems with that. I'll set up another problem. So here we go. 2.0 liters of gas at 298.15 Kelvin, and 1 atmosphere is compressed and heated to 1 liter and 400 Kelvin. What is the final pressure? So we just write this down. Always write down what you know. The initial volume V1 equal 2.00 liters. Put a unit on it. T1 equal 298.15. Let me fix that. And P1 equal 1.0 atmosphere. And then I write down V2 equal 1.00 liters. And T2 equal 400 Kelvin. And finally, P2 equal that. And so we go P1 V1 over T1 equal P2 V2 over T2. We solve for P2. And so I get P1 V1 over T1 times T2 over V2 equal P2. This is straightforward algebra. If you don't know what I did, I multiplied both sides by T2 over V2. That cancels this side and the P2s, and I'm left with this formula. Okay? So all you got to do now is plug my numbers in. P2 is equal to P1, which is 1.00 atmospheres, right here, times V1 times T2. So I'll put all those in there. 1 atmosphere times V1 is 2.00 liters times T2, which is 400K, divided by T1 up here, 298, V2, 1.00 liters. So when I do the math, I get 2.68. And let's see what our units are. My liters cancel, my Kelvin, and I get atmospheres. So that'll help you make sure your units cancel. And that's it. You just got to be able to solve and dig out from the word problem what your variables are right here. And you got to dig them out of the word problem, write them down like this. This will help. And figure out what to solve for. Straightforward problem.